Abigail for number 15 in Unit 10. This is modeling quadratics and inequalities. But in number 15, it says Abigail tosses a coin off a bridge into a stream below. Which of the following quadratics models would best represent the height of the coin, h, as a function of time, t, since it was hit? So, kind of having a good picture of this scenario will give you an idea of maybe what function would work. So, bear with me with my drawing. It's not going to be, I'm not an artist, so, but let's just say here, we have our bridge, okay? And here's Abigail, stick figure. She's standing on our bridge, okay? And then here's some water below, okay? Abigail then tosses a coin from her hand, so here's her hand. She tosses a coin, and then it lands in the water, okay? So, kind of the path of the coin is what our quadratic looks like, okay? And here's our path, right here. So this is kind of what our quadratic looks like. So you have to figure out which one of those matches that quadratic. So if you notice, our quadratic is opening downward. It kind of has this U-shaped curve where it's opening down. So we know when a quadratic opens downward, a negative has to be out in front. The leading coefficient is negative. So the only ones where our leading coefficient are negative are A and C. B has a positive leading coefficient. That 16 is positive. That's not going to be an answer. And D also has a positive leading coefficient, so that's not going to be an answer. So at least we have a 50-50 shot. Now we have to think about where's the coin starting, okay? The coin is starting really high above the ground, starting really high above the water, okay? And the part of our graph that always represents our starting point is the y-intercept, okay? So the y-intercept always equals where you start from, your starting point, okay? So the y-intercept representing where the coin started, and the coin started in Abigail's hand, okay? If we look at our functions, if you remember, this back number always represents your y-intercept, okay? So this one has a y-intercept of -12, or 112. This one has a y-intercept of +112, okay? Well, if we're dealing with real world, you can't have real negative distance, right? This A is stating that the coin started -112 feet, feet, I'm going to go with feet, doesn't say in the problem. And this is saying a positive 112 feet. Well, you can't have negative distance, okay? -112 is saying that the coin started below ground. Well, clearly the coin started above ground, so it has to be C. Okay. Take a look at the next one. 16. 16 says the height of a missile t seconds after it has been fired is given by -4.9 t squared plus 441 t. Which of the following represents the number of seconds it will take for the rocket to reach the greatest height? Okay. Whenever you see maximum height, greatest height, minimum height, lowest height, something along those words, maximum, minimum, lowest, highest, you're trying to find the turning point. Okay, that's what you're trying to find. In this case, if we're finding the greatest height, the turning point is going to be a maximum. So what you're going to do is you're going to use your calculator. So you are going to go to y equals in your calculator. I already have something plugged in there, but clear out whatever in there, and you're going to plug in this function, -4.9 t squared. So -4.9, just use the variable button, just use x, that's the same thing as t. Okay, don't do alpha t, that's something totally different. So just use x. -4.9 t x squared plus 44.1 x. I know it says t, but they're representing the same thing, just a variable. Make sure you put that plus sign in between. Plus. Okay. There we go. Make sure it matches. So I'm just going to double check. Yes. Okay. So then you're going to hit graph. If you notice, I do not see the top part of my graph. That means we need to adjust our window. And when you adjust your window, you need to guess and check. So think about what the scenario is going on. We're launching a rocket into the air. Okay. My window's probably going to be pretty high. Okay. My X values look okay because I can see where it lands. It lands right here. Okay. So I can see where it lands. I need to adjust my Y value in my window. To adjust your Y value in your window, go to Window. Okay, my X values are fine, but I'm going to adjust my Y's. Okay, I'm going to adjust it. I'm going to keep it at a little bit below zero. So I'm going to do -5 just so I get a good picture of where it lands. But I'm going to go to like 200, and I'm going to count by 25. I'm launching a rocket up in the air. It's going to go pretty high. So I'm going to make my Y max 200. I'm going to make my Y min -5 just so I can see where it hits the ground still pretty well. And if I'm going from -5 to 200, I'm going to count by 25s. Counting by ones is not going to give me a good picture. So I'm going to hit graph. And there we go. Okay, now I can see the top of my graph. I adjusted my window. So when you have to adjust your window, you just need to guess and check till you can see the entire picture. We can see the entire picture, so we're good. Okay. So now we want to figure out what our maximum is. So you're going to use that second. So hit second, and then trace. We're trying to find the maximum, so you're going to go to maximum. You're going to go to 4, and hit enter. The left bound of your maximum is just the left side of where you think your maximum is. So you go a little bit to the left and hit enter. The right bound is a little bit to the right of where you think your maximum is and hit enter. And then you just kind of guess. You go in between those two lines and arrows. So there's our maximum. It's about 4.5 as my X value and 99.225 as my Y value. 4.5 and 99.225. So there's my maximum. Here's the thing. You only want to know one of those values for my maximum. Okay? So look at what it's asking. It says, which of the following represents the number of seconds it will take for the rocket to reach its maximum height? So when it's asking for number of seconds, it's talking about time. So if we look at our function, time is being represented by t, which is representing x, okay? So we are going to look at the x value of our vertex, and the x value of our vertex is 4.5. So our answer is B. And a little hint, whenever they're asking for you how long it's going to take something, okay, what's the time, number of seconds, how long, you're always finding x. It's always the x value of whatever you're looking at. Just a little. Okay. So if we take a look at the next one, number 17. 17 says a ball is thrown in the air. The path of the ball is represented by the equation -t squared plus 6t. Graph the equation over the interval from 0 to 6 on the grid provided and use the graph to answer the following questions. So again, we're going to use our calculators to help us with this. We are going to take our function and plug it into y equals -t squared plus 6t. So I'm going to go to y equals, clear out what's in there, and do -6t squared plus, I forget it already. Oh, I messed it up. -t squared plus 6t, sorry. -t or x squared plus 6x. Again, if it's t, just type it in as x in your calculator. Just use that variable button. To graph it on that grid, we are going to use our table. So once you plug that into y equals, hit second, graph, to get your table. Okay? And the directions say to graph it over the interval from 0 to 6. So that means graph all the points from where x is 0 to 6. So we are going to graph those points. So I'm going to move the table over to the smart board so we have a visual. We're only plotting the points from 0 to 6. Okay? So I don't have to keep flipping back and forth. So we're only plotting from where x is 0, because t is representing x, to 6. So I'm going to plot my first set, 0, 0. I'm going to plot my next set, which is 1, 5. Plot my next set, which is 2, 1, 2, 3, 4, 5, 6, 7, 8. 3, which is 2, 3, 4, 5, 6, 7, 8, 9. 4, which is at 8. 5, which is at 5. And 6, which is at 0. So here's our graph. Connect your points. Okay? That graph is representing the path of the ball. Okay? A asks, what is the ball's maximum height? In other words, what's the highest the ball goes? So if we look at our graph, here's the highest where our ball goes. It's right here. If we count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it went 9. And very careful, label your answers. Meters, sorry. Right there it says meters. I thought it said in the directions. It says meters right there. So it'd be 9 meters. Make sure you label your answers. B says, what time does the ball reach its maximum height? Okay? Well, y is representing how high it went. X or t is representing how long it took to get there. Well, again, here's our maximum height. Go to count, see what x value is there. And the x value is 1, 2, 3. So it took 3 seconds for that ball to reach its maximum height. And again, that's what it said time was being measured in seconds. After how many seconds does the ball hit the ground? Okay, well, again, go to your graph. Here at this blue point is where the ball hits the ground if we count. That's 1, 2, 3, 4, 5, 6. At 6 seconds, the ball hits the ground. D says, at what height is the ball thrown from? Whenever it asks you from where it's thrown from or where it starts from, again, that's the y-intercept. Okay? So if we go to our graph, go to where it's crossing the y-axis, it's crossing the y-axis at the origin. Okay? So the value at the origin is 0, 0. Okay? And then E is saying over what interval is the ball falling towards the ground. So that means it's going downwards. So it's starting here at the maximum, and then it goes down till it hits the ground. So when you write the interval, you're writing it in terms of x. But in this case, technically t, because that's what's representing x. And we have to put our symbols. It's not technically falling towards the ground at the maximum, and it's not technically falling towards the ground once it's on the ground. So you don't put inequalities underneath your, or lines underneath your inequalities. You just write your inequality symbols. So where it starts falling towards the ground, the x value or t value there is 3. And when it hits the ground, we said was 6. So from 3 seconds to 6 seconds, that is when the ball is falling towards the ground. I think that's all from Unit 10. Yep, that is all from Unit 10.